this is Miss Bufford, and in this video we're going to talk about atomic structure and ions. Your learning goals are to be able to diagram and label the parts of an atom and determine the mass and charge of subatomic particles, to be able to explain the difference between atomic number and atomic mass, to be able to explain the difference between a neutral atom and an ion, be able to distinguish between a cation and an anion, and understand and be able to write the nuclide symbol for neutral atoms and ions. And so the first thing that we're going to review is just the structure of an atom. And so in the nucleus, which is this central area right here, we have protons that contain a positive charge, neutrons that have no charge, and then in the outside the nucleus, orbiting the nucleus, we've got electrons that have a negative charge. And so what is the atomic number? The atomic number is equal to the number of protons an atom has in its nucleus. And this also will identify the element that you're dealing with. So, for example, helium's atomic number is 2, and that means that helium has 2 protons in its nucleus, and all atoms of helium will always have 2 protons in the nucleus. If it doesn't have 2 protons in its nucleus, it's not going to be helium. The elements in the periodic table are arranged in order based on the number of protons they contain. So across each row, each successive element contains one more proton than the last. The atomic mass is going to be equal to the number of protons plus the number of neutrons that an atom has in its nucleus. So this gives us the overall mass of the atom. And just to give you guys an idea of the relative masses of the protons, neutrons, and electrons, you can see here that, the mass of a proton and the mass of a neutron are roughly similar. We usually round that to just 1 atomic mass unit. But you can notice how tiny the mass of an electron is. And so if we were to round that up, we'd end up with 0. So why don't we consider the mass of electrons when determining the mass of an atom? That's just because their mass is so tiny, it's pretty much negligible when we're talking about the masses of these atoms. And so we only add protons and neutrons to determine the atomic mass for an atom. And then the masses for the elements can be found on the periodic table, usually below the element symbol. All right, so now let's talk about neutral atoms versus ions. So a neutral atom has equal numbers of protons with a positive charge and electrons with negative charges. So their charges are going to be equal in quantity, so they cancel each other out, and that's what makes these atoms neutral. But some neutral atoms are not stable when they have only equal numbers of protons and electrons, and they tend to undergo chemical reactions in order to gain or lose electrons and reach a more stable electron configuration. When they do this, they become ions. Some elements on the periodic table are more likely to lose electrons, and others are more likely to gain electrons. And we'll talk more about that when we start talking about our chemical bonding unit. But the charge on an ion is always going to be equal to the difference between the number of protons and electrons. So when we're trying to find the charge, then you just take the number of protons and you subtract the number of electrons. If an atom loses electrons, it becomes positively charged. And this is because it has more positive charges than negative charges. And this becomes, any positively charged ion is called a cation. So that's just a more specific way of talking about ions. For example, if a sodium atom, this is a type of atom that tends to lose electrons in a chemical reaction, it tends to lose its outer electron. And when it does this, gives it away, the sodium atom becomes a sodium ion, and it loses a negative charge when it gives away that electron, so it becomes positively charged because it still has the same number of protons, but it lost a negative charge, and so now it's got more positive charges than negative charges. And we can call this a sodium ion, or if we wanted to be specific, we could say it's a cation, and that would indicate that it's got a positive charge. But if an atom gains electrons, it becomes negatively charged because it has more negative charges than positive charges. And for example, chlorine is a type of element that tends to gain electrons during chemical reactions. And when it does this, it gains an electron, it's gaining a negative charge. And so now it has an imbalance and it has more negative charges than positive charges. And so it becomes a chloride ion. Or if we wanted to be more specific, we could say that was a chloride anion. And that would tell us that it's got a negative charge. All right, so now let's talk about nuclide symbols. These are symbols that just give us a lot of information about an element. So a nuclide symbol, if you wanted to write this, includes the element symbol from the periodic table. It includes the atomic number. So remember, the atomic number is the number of protons, and that would go in this lower left-hand corner. It contains the mass number, and remember, that's the number of protons plus neutrons, and that goes in the upper left-hand corner. And then if you're dealing with an ion, then you want to also list the electrical charge. If it's a neutral atom, then you don't write anything up here for the electrical charge. But if it does have a charge, and you can determine that by the number of protons minus the number of electrons, and you would list that charge up there in the upper right-hand corner. All right, I hope this video was helpful. Please let me know if you guys have any questions. Thank you for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.